You know that box in your kitchen, the one that reheats leftovers in about 2 minutes flat? Well, it has a secret history, and I mean a real secret history. We're talking about top secret World War II radar technology, a brilliant, self-taught engineer, and a powerful, invisible force of physics, all discovered completely by accident. Let's get into it. It all starts with this one simple observation. In a high-tech Raytheon laboratory back in the 1940s, someone noticed their chocolate bar had melted. This tiny little moment, this was the spark for a technology that would completely change how the entire world eats. So, the man with the melted chocolate was Percy Spencer. He was an engineer working with these things called magnetrons. They were the powerful heart of radar systems. You know, the tech used to spot enemy planes. He was just standing next to one of these humming machines, a serious piece of military hardware, not exactly a kitchen gadget. But that was all about to change. Now, Spencer was a really curious guy. He didn't just shrug and toss the melted candy. He saw it as a clue. So what did he do? He decided to experiment. He grabbed some popcorn kernels, put them near the magnetron, and boom, they popped all over the lab. Then he tried an egg, and, well, it promptly exploded. So through all these messy and, explosive experiments, the big idea became crystal clear. The invisible radio waves, the microwaves coming from the radar equipment, they could heat food, and they could do it unbelievably fast. Okay, so how does this invisible fire actually work? What is the science that can turn a solid chocolate bar into a gooey mess without a single flame or a hot coil in sight? Microwaves are just a form of energy, a lot like the radio waves that bring music to your car. The key term here is non-ionizing. All that means is that they aren't the scary kind of radiation. They aren't strong enough to damage your cells or make your food radioactive. The specific frequency was actually chosen because it's fantastic at heating food, but doesn't mess with important communication signals. So here's the magic. Pretty much all food has water molecules in it, right? And these tiny molecules have a positive and a negative end. When the magnetron fires up, it floods the oven with microwaves, and these waves are flipping their electric field billions of times a second. The little water molecules in your food frantically try to align with this flipping field, spinning back and forth like crazy. All of that spinning and bumping creates friction on a molecular level, and that friction creates heat, cooking your food from the inside out. So knowing how it works is one thing, but turning a massive piece of military tech into something that fits on your countertop, now that's a whole different challenge. Let's take a look at how this technology actually evolved. The very first commercial microwave came out in 1947. It was called the Radarange, and just look at this thing. It was an absolute monster. We're talking almost 6 feet tall, weighing over 300 kilograms, that's like 750 pounds, and it cost more than a brand new car. It was really only used in places like restaurants and on ships. It was a long, long way from being in anyone's home. It really wasn't until this decade, the 1970s, that the technology finally caught up. They figured out how to make microwaves smaller, safer, and, this is the big one, affordable for the average family. This is the moment the real kitchen revolution began. Okay, so we've got the history. Now let's answer some of the most common questions people have about the little box sitting on their own counter. You know, what's really going on in there? First up, probably its most iconic feature. Why does the food have to spin around and around? Is it just for show? Nope, not at all. So the microwaves bounce all around the inside of that metal box, and this creates pockets of high energy, hot spots, and areas of low energy, cold spots. If your food just sat still, parts of it would get scorched while other parts would still be frozen. The turntable is the solution. It makes sure every part of your food gets a turn passing through those hot spots, so you get much more even cooking. All right, next question. You can see your food cooking through the door, so why don't the microwaves leak out and cook you? What's the deal with that dotted metal screen? That screen is just brilliant physics in action. It creates something called a Faraday cage. The little holes in that mesh are smaller than the microwaves themselves, so the waves are just too big to escape. But visible light waves are much, much smaller, so they can pass right through, letting you safely watch your cheese melt. And now for the big one, the question that has followed this appliance around since the very beginning. Is the food that comes out of a microwave actually safe to eat? The answer, according to all the science, is a clear, unambiguous yes. So let's just quickly bust the two biggest myths. First, like we covered, microwaves are non-ionizing. They just make water molecules dance. They don't have the power to change an atom's structure or make anything radioactive. And second, the myth about destroying nutrients. Actually, the opposite can be true. Because microwave cooking is so fast, it can preserve more of those heat-sensitive vitamins, like vitamin C, than longer cooking methods, like boiling or baking. You know, when you really step back and think about it, this invention, born from a melted chocolate bar in a war lab, it did so much more than just heat food. It fundamentally reshaped our daily lives. The microwave turned leftovers from a chore into an instant meal. It's the reason the entire frozen food industry is even practical for the average person. But really, its biggest impact was on our most precious resource, time. It literally gave us back minutes, sometimes even hours, every single day. And that just captures the magic of it perfectly, doesn't it? It's this quiet, unassuming box that commands an invisible energy and turns it into the simple, comforting warmth of a meal ready in moments. It really makes you wonder, right? From a military lab to almost every kitchen on the planet, all because of one moment of simple observation. What other world-changing technologies are hiding right out in the open, just waiting for a curious mind to notice?